All right, so if I were to ask you guys, what is bigger, 2 to the 5th or 3 to the 3rd, a greater value, there is a little bit of key concept or prior knowledge that you have to know in order to answer that question. And that is all about what I like to call exponents. Now, there's different rules and stuff you have to use for exponents. So let me just go ahead and explain what an exponent is and what it really does. So notice that you have a big letter here, B. That is what we like to call the base. Notice that we have an E in that little space on the top right. That is what we like to call an exponent. And literally, just like anything in math, is you just need to understand what the relationship is or what the operation is. What are they telling me to do? And the way I like to think about it is, okay, I am going to take my base and I'm going to multiply it by itself an exponent amount of times. So if we have something like 2 to the 5th, I can see that my base is 2 and my exponent is 5. So I'm going to multiply my base that exponent amount of times. So here's my 2. That means I'm going to take 2 to the 5th, and that is the same thing as taking that base and multiplying it by itself 5 times. Let me double check to make sure I got 5 times. 1, 2, 3, 4, 5. So this is what is called exponent form. Because notice that you have an exponent. This is what is called expanded form. It's called expanded because you can tell that it's expanded out however many times you're going to multiply. Now, of course, some numbers are easier than others. Some are going to be easier in exponential form to figure out. Some are going to be a little bit easier in expanded. Now, when I'm doing 2 to the 5th, it is pretty hard to multiply all that in my head. But we'll try our best. What is 2 times 2? 4 times 2? Times 2? Times 2? 32, right? 32. So 2 to the 5th equals 32. Now, notice that we also have 3 to the 3rd. Now, again, notice that your base is 3, your exponent is also 3. But remember the relationship that you're going to take that base and multiply the exponent amount of times. So we're going to take 3 and multiply it by itself 3 times. Don't think of it as 3 times 3, okay? That's the biggest mistake that happens, especially during a test when you're in a hurry. So let's just start doing this. What is 3 times 3? 9. Now, if it helps you, go step by step. I like to cross them out so that way I can see what I multiplied and what I still have to. And then I can clearly see here that I still have to multiply 9 times 3, which I believe equals 27, correct? So when I compare these two numbers, which one is bigger? 32, 2 to the 5th. So this unit is going to be all about properties of exponents. My hope today is to give you a really good basic foundation and just start building on it each and every single day. So this is a unit that, how would I like to say, doesn't really, like I just said, build on itself, but the problems get more difficult because there's a lot more work to be done. So the practice is absolutely necessary. So let's start with the basics. I want you to expand the following. So if you remember, this is in exponential form. This is 3 to the 4th. When I say, hey, expand this, I don't want you to actually tell me what 3 to the 4th is. I just want you to change the way it looks. So remember that we have a base of 3. We have an exponent of 4. So we're going to take that base and multiply it by itself an exponent amount of times, which in this situation is 3 times itself 4 times. So that is what exponent literally is, or what I would say, going from exponential form to expanded form. And that's all I want you to do. I want to make sure that you understand what an exponent is. Now, what do you think? If we have a variable like a raised to the 5th, is that really going to change our thought process or the concept of what an exponent does? No. We're still going to have a base of a, and we're going to multiply it by itself an exponent amount of times, which is 5. So this is going to be rewritten or expanded out as a times a times a times a times a. So what I want you to do is to do the other problems, and you'll notice that it gets pretty routine, right? It's not a crazy hard concept. Just keep in mind that number 5 and 6 could be a little difficult, but apply the same concept that we covered, and you'll be all right. So try these problems out. I'll walk around to see if I could clarify or do anything for you. All right, guys. So I believe we left off on numbers 4 through 6. So let's go ahead and do number 4. So notice here that I have a base of b and an exponent of 2. So remember the operation that you're just multiplying the base, the exponent amount of times. So we're multiplying b by itself 2 times, and that is how you expand it out. Now notice here that I have 2 variables, but I'm not going to let that scare me because remember, this is just all multiplication. So when I see g raised to the 3rd, I just know that I'm going to multiply g 3 times. Now, don't forget that you're multiplying towards h to the 5th, so you're just going to multiply it by h 5 more times. 1, 2, 3, 4, 5. Just double checking because I kind of mess that up once in a while. So just because you have multiple variables, don't let it freak you out. Keep in mind that when you have variables with nothing in the middle, it is multiplying. So when you expand it, you know you need to show your multiplication throughout. Now notice in this one you have 2 raised to the 3, so you're going to take your base of 2 and multiply it by itself 3 times. Don't forget that it's multiplying the b to the 5th, so you're going to multiply it by b 5 more times. And that is exactly how you expand it out. Now, that's not only do I want you to be able to take an exponential form and expand it, I also want you to be able to work backwards. So I want you to expand, go from expanded to a normal one. So I want you to try out these problems right over here. I'll give you guys roughly about 40 seconds because these are either you know it or you don't problems, right? So we'll go over it in a quick second afterwards. All right, so notice before I gave you something in exponential form, and then I asked you to expand it. But now I gave you an expanded form and told you to change it to exponential. Now remember that when you're doing exponentials, you're really just multiplying. So whenever you have something like number 1, and you can notice that this is 5 times 5 times 5, what are you multiplying by itself over and over and over? 5. How many times did you multiply it? 1, 2, 3. So notice that I can rewrite this as 5 to the 3. Now let's look at number 2. Notice that I'm multiplying the same number by itself. That means I can rewrite it as a base, and how many times I'm going to multiply it is going to be the exponent. There's 1, 2, 3, 4, 5. Did I count that correctly? Yes. Now notice that I have number 3. I notice I'm taking the number -3 and I'm multiplying by itself twice. So that means I can take that -3 and square it. Now, there is something absolutely tricky here that you absolutely have to know. It's one of the biggest misconceptions that happen in all of math, especially even in Algebra 2. Notice the way I rewrote it, it reads as -3 squared. Now notice that if you were to type -3 squared in the calculator, what would you get out? Sorry? Oh, if I take -3, so let's say I have -3 times -3, I rewrote it as -3 squared. If I were to type this into the calculator exactly the way it shows up, what do you think it'd be equal to? 9? Okay, now let's go ahead and do this because there's something that always happens that a lot of students get wrong on multiple tests. Even my Algebra 2 students do this consistently. Notice that you have -3, and if I square it, everyone said it was going to be a 9, correct? But look what happened. What popped out? -9, and then there's a bad test score off a simple mistake. What happened here? Why this doesn't make sense? This is -3 times -3. You should go a +9. Why, when I typed it into the calculator, it came out to a negative? Anybody have some ideas? The good thing is that it's really straightforward. When you see the base here and you notice that it's negative, you know that your base is a -3. But when you raise it to an exponent, you have to tell yourself, the calculator, the reader, that everything that's included there is getting squared. You have to have those parentheses, because if you don't, what you're really telling the reader, what you're telling the calculator, this is why this is a horrible unit to have with your iPhone when you do the little squares. If you do -3 squared, the calculator reads this as a negative whatever 3 is squared. It will square the 3 to equal 9, but it will be like, hey, that negative has nothing to do with the square, so we'll leave it on the outside. So I am going to grade you guys on this, that if you're asked to expand, and your base is negative, you have to have those parentheses out, because again, if I dock you guys down, hopefully you guys will remember it forever, and when you move on to future maths, you'll be all right. And you can see what happens as soon as you put the parentheses in your calculator. Let's say we do have parentheses and we put a -3. We go on the outside and we actually square it. You'll notice that it does give you that +9 that we're looking for. Super, super important, especially in Algebra 2. It's one of the biggest things that students miss little easy points on. So let's go ahead and do the rest of these problems just to make sure that we got them now. So notice that I'm multiplying 6 by itself multiple times. That means I could rewrite my base. I can write -6 as a base. Now, how many times am I multiplying this? 3 times. Am I correct? No, what did I just say? Not to forget when your base is negative? Your parentheses, because you have to tell the reader, hey, my base is a negative, I'm going to include it in the exponent. It's what's multiplying itself multiple times. Now, you probably would get, not probably, you would get the same answer, but just to be safe, again, put those parentheses. All right, now notice that I have multiple numbers multiplying some multiple times. It gets kind of weird, but take it one step at a time. These are all multiplying each other. Notice that you're multiplying 2 twice. So you can rewrite that as 2 raised to the second power, because notice that you're taking into account that you're multiplying it twice. Notice that you're multiplying it by 3 how many times? 3 times. So you could rewrite this as 2 to the second times 3 to the third. Next one. First thing I see is my base of 6, because I'm multiplying 6 1, 2, 3 times. So that could be written as 6 to the 3. Notice that I'm multiplying it by 4, 1, 2, 3, 4 times. So this could be rewritten as 4 to the 4. So don't get, how would I say, hung up on the 2 numbers. All right. So notice in the other problems, what I asked you to do was one was I showed you an expanded form, and then I told you to put an exponential. And then I gave you exponential and put it to expanded. Now I'm telling you to simplify. I want this to be simpler. I want you to simplify one shape or another. Now, this is what's absolutely key. You need to understand the rules of exponents to understand how to simplify this. So let's look at this a. How many times am I multiplying a according to this exponent? Twice. Now notice I'm multiplying that to a to the third. Now, if you're multiplying it, if you have an a raised to the third, how many times are you multiplying a? 3 times. So notice that if we could expand it, it's really obvious to see how we could simplify our original by expanding it back. Because how many times are we multiplying a in total? 5 times. So that it ends up being a to the 5th. So notice that I took my original problem they told me to simplify, and I made it look way simpler because I combined the bases. Now, notice in the second problem here that I have a to the 23 and a to the 7. Do you want to write a 23 times? No, so what's a shortcut? If you are multiplying 2 like bases, what can you do to the exponents to do a little shortcut and not have to do all this expanding? What do you do to those exponents? You add them. That's absolutely right. So if you have a to the 23 times a to the 7, now keep in mind they have to be multiplying. Your base stays exactly the same, and all you have to do is add the exponents, because 23 plus 7 is 30. So when you multiply like bases, you add the exponents. All right, what happens when you're multiplying multiple like bases? Does that really change anything? No, your base is going to stay the same because you're still multiplying it over and over again. And what do we do with all the exponents? Add them. So it's just 5 plus 5 plus 5, which equals a positive 15. All right, let's look at number 4. What do you guys notice about 4? You have 2 variables now. Are you really going to let that freak you out? No. Let's start with the base of a. Notice that all these guys are multiplying because there's no sign in the middle. You have an a here, you have an a here. How can you simplify those a's in terms of their exponents? What would you do to their 2 exponents? Add them. 5 plus 7 is 12. Notice that you have c's here. 3 c's. How would you simplify their exponents? Add those ones. So you end up with 5 plus 5 plus 5, which equals a positive 15. So you can see here as we're working through these problems that this is what I mean about it's not hard, the math, but it can get a little tricky. Really easy to miss little things. Now I'm going to challenge you guys to do numbers 5 through 6 on your own. I'm going to give you like 15 seconds because, again, either you know these or you don't, right? All right, guys, so let's do 5 and 6. So keep in mind that whenever you're dealing with exponents, what you're really dealing with is repeated multiplication over and over. It's just a shorthand way of just, again, multiplication repeated over and over. So notice that on number 5, I have a bunch of bases that are multiplying each other. Now, again, all you're really doing is you're simplifying ways. You're combining all the like bases just to make it look simpler. Now, notice this is 4 times all this garbage. Now, is there any way I can combine the 4 with the G, the A, or the other G? No, it's just the 4. There's no way to combine it, so I'm just going to rewrite it over. Notice I have 2 G's. They are getting multiplied. Again, when you're multiplying 2 like bases, what do you do to their exponents? Add them. Now, notice that we have an A to the 5th. There's nothing really there. So let's just rewrite it over. Now that's about as simplified as it gets. There's not really much else you can combine. Now on the answer key, they're always going to ask you to put your variables in alphabetical order. Now I'm not going to have you guys do that. As long as you guys do the actual math right, or the combining correctly, I'm okay with that. I'm not going to really worry about, you worry about your ABCs when doing math in a way, okay? All right, let's do the next one. Now notice that we have 10 times c to the 10 times b to the 5th times 3 times c cubed. Now remember, what are all these bases doing to each other? Multiplying. Now notice that you have a 10 times 3. Do you know what 10 times 3 is? Yeah, so just simplify those. AKA, whenever you have coefficients, constants out, just multiply them like normal. And then start dealing with the bases. The variable basis to be exact. Notice you have a c to the 10 and c to the 3rd. I'm going to combine those by adding their exponents. Notice that your b to the 5th is just really hanging out. So you can see that this gets simplified to 30c 13b to 5th. All right, one more set of problems and then we'll call it a day and give you guys some more individual practice here. So I'm going to challenge you guys to think of how in the world can I simplify problems like 1, 2, 3, and 4. All right, guys, so there's a couple key concepts here that I want to make sure that you guys understand before even doing the problems. Now, notice here that you have x to the 5th divided by x to the 3rd. A lot of people see a fraction and they automatically just see a fraction, but a fraction is just a fancy way of showing division. So notice that again, we have x to the 5th divided by x to the 3rd. Now, it is our job to simplify this, make it look simpler by combining the bases in one shape or form. Now, it's pretty hard to see what you're supposed to do in exponential form, so let's expand it. Now, if I look at my numerator, which is on top of the fraction, how many times am I multiplying x? Did everybody say 5 times? Yeah, exactly. Now, how many times do I have x in the denominator? 3 times. So that means I'm going to multiply x 3 times. Now, you can clearly see here, if you divide something by itself, what do you end up with? 2 divided by 2. What's 2 divided by 2? 1. What's 20 divided by 20? 1. So notice if you have x divided by x, what does that equal? 1. 1 times anything is just going to be itself, so you're going to be left with whatever you have. But as you can see here, you could actually start canceling out a little bit more. Notice that if you divide those x's, that would equal 1 because something divided by itself is 1. Something divided by itself is 1. So what are you left with? You're left with what? 2x. Yeah, with 2 x's. And how can we rewrite that in exponential form? x2, or x raised to the 2, right? You have to get that little math in the vocab to make sure you're to the exponent. So what do you guys notice here? What's a shortcut way that I could do in order to get from my original to my simplified form? Because I don't want to have to do expanded form each and every single time. We're really just doing expanded form to help us pretty much see the patterns and ignore them after that. Yeah. 5 minus 3. Yes, a really quick rule. If you're ever dividing 2 like bases, in order to simplify, all you have to do is subtract the exponents. That is literally all you have to do. But keep in mind that these can get a little bit tricky, and this is what I mean. Notice that if I were to expand this guy over here, I would end up with 5 b's on top. 1, 2, 3, 4, 5. Now it end up with 10 b's at the bottom. 1, 2, 3, 4, 5. And notice that now when you start canceling out, or not canceling out, dividing out, right? The same things divided by each other, what are you left with? 5 what? B's. But where are they located? Are they located in the denominator or in the numerator? The top or the bottom of the fraction? The bottom, which is known as the denominator. So whenever you simplify this one, you know that your denominator has to be, or your simplified base has to be in the denominator. Now notice that there's nothing on top of my fraction, which is absolutely mathematically incorrect. You always have to have a place value. That place value always has to be 1. Now, just like always, we want to come up with shortcuts when simplifying, because the point of simplifying is to make things look simpler in order to help you out. Now, what is a way that we could what can we use as a rule of thumb? Does anybody have an idea of what can I do to help me figure out where my base with my simplified exponent goes? Any ideas? None? Aw, come on, guys. You guys got this? Let me show you. Again, if you were dividing two like bases, what do you do to simplify their exponents? You subtract them, right? Now let's look at this first one. Notice that I can see that I am dividing two like bases, and I have their exponents right over there. Which exponent, or which variable has a bigger exponent? The exponent in the numerator or in the denominator? Numerator. So that is a rule of thumb that, okay, if I'm simplifying two bases that are getting divided, I'm going to keep my base in the same location of the fraction that has the bigger exponent. So notice that this x has a bigger exponent of 5, so that means that my x is going to end up on top. And then I'm actually going to do the math. This exponent minus this exponent, which equals a positive 2. I already have it in the numerator. I don't need anything in the denominator, so I can move on. Notice that I have this one over here. I have a base of b, a base of b. That means I can combine those bases by subtracting their exponents. Now, where's there a bigger exponent, in the denominator or the numerator? The denominator. So that means your base is going to go in the denominator, and then you go ahead and do the math. 10 minus 5 is 5. You just have to remember that when you don't have something in the numerator, you have to have that place value of 1. So that could be a rule of thumb to help you guys out. Just kind of see which one has a bigger exponent, because you know that if they were to cancel them out, you would have more in whatever one it is. All right, so this will be the last problems that we do. Try these 4 problems, and then we'll go over them in about, I don't know how much time you guys need. All right, guys, so let's see number 4. So if you look at number 4, notice that you have a base of x divided by a base of y. Now, can you combine two bases that are not the same? No, right? Because, of course, you have to have the same bases. So when this happens, the best you can do is just rewrite it over and say, hey, it's as simplified as it's going to get. There's nothing I could do. Now, I know that might seem confusing, especially when I'm having you practice these for the first time, but it's super important that you guys see I can only combine the bases that are exactly the same. And it doesn't matter if they're also numeric numbers. So notice you have 5 to the 6 and 5 to the 4. So notice you have the same base of 5. What has a bigger exponent, the numerator or the denominator? The numerator, because again, this is a 6. So your base is going to go in the numerator. And then notice you do the math with the exponent. 6 minus 4 is a positive 2. Now, I believe the answer key just leaves it as 5 over 2, but you can simplify it if possible. 5 to 2 is 25. But I'm going to be okay with this for today. We're going to worry about that when we build on this tomorrow. All right, last but not least, notice that you have 2 numeric numbers of 9. There's more 9s in the bottom, so I'm going to put a 9 at the bottom. And then what I mean by the bottom is the denominator, right? And then subtract the exponents. 5 minus 2 is 3. Don't forget your place value of 1, okay? Don't forget it. Now, these are the key concept here is pretty much memorizing. Not really memorizing, right? Because you could always kind of revert back. So these two properties are really called the product property of exponents and the quotient property. And the product property just states that if you have two like bases, let's call them a times a, and let's say they have an exponent of b and c. If you are multiplying two like bases, your base stays the same, but what do you do to the exponents? You add them. So that is, again, just putting a name to what we're doing. And this is the property, the product property of exponents. Now, how about quotient? Let's say we're taking some other random a to the b divided by a to the c. When you're dividing two like bases, what do you do to their exponents? Subtract them. So, and that's pretty much the key thing that you want to use that rule. Make sure you got it. And that's it for today. The rest of the day is just for you guys to do your practice.